promising presentation. Everybody really pumped to talk about stats? I'm here to talk about stats. I've spoken at, believe it or not, some other conferences and written some stuff, and I've worked with some acronym agencies, and I've worked with software security for long enough that I've completely frizzle-fried and brain. So right now I work with white hats, and we do some interesting stuff trying to take people-driven methodologies and automate them, make them scalable and repeatable on a scale no one's done before. It's very interesting. So this presentation, the goal of this presentation is to give you some hard math, to give you some statistics, and I hope, before we get into the actual slides about the math, I want to illuminate something that seems really bizarre about our industry to me, because there is no math. There's no like metrics and measurement models, and we're one of the only industries kind of introduce this. What I'd like to pull up, actually we'll skip that slide here. So here's the deal. Earlier this century, I got kind of fed up with automated tools and the insane marketing hyperbole promoting many of the protection solutions, so I approached Jeff Williams at Owasp about starting a metrics and measurement project, and I wanted to evaluate software security automation and protection tools and analyze their degree of effectiveness, effective these solutions. So the idea was that a smart group of humans would various scanners and WAF solutions and measure them and see how well they found the issues or protected against them. So it turned out I was ridiculously naive about the scope of this project. I found out there were about 3 times more approaches and 20 times more solutions than I realized. One time I had over 50 software security analysis tools and 9 WAFs in my lab for testing. It was pretty messy. So my resulting work was pretty amateur and incomplete, and later mildly better jobs. One was an employer that didn't want to risk alienating product vendors. Another were publishers that wanted to keep the peace with everyone. So, and then of course, if you've ever traveled as a consultant, you get the overwhelming travel schedule effect. So where are we now? Well, now what we're trying to do is pick up this, pick up the torch of accountability for math and introduce some statistics back into our industry, some metrics of measurement. And this would be, yeah, there we go. Measurement, you get it? It's a ruler. It's subtle but clever. So now we're going to talk briefly about the past, because I know you came here to hear about the past, how we got here today. So in the 1500s, I love this, there's a Scotsman that wrote a book called Inquiry Concerning Human Understanding, Big Hume. And he gave us some poignant words concerning books at the time, claiming to deal with matters of fact and existence. He said, if it contain no questions concerning quantity or number, commit it to the flames then, for it is nothing but sophistry and illusion. So that's kind of where we're at today. We don't even really have good books about this. What does this tell us about Web AppSec? Well, there's a problem in the AppSec industry, and it's ironically similar to one, bear with me, hang on, it's similar to one that pre-Renaissance Christians ran into when they were dealing with over the top 10 list the Christians had, and a couple of them, actually the Catholics. So, the problem, my friends, is actually one of math, right? We need to ask more questions concerning quantity and number, and we need to demand answers. However, in today's landscape, we're unlikely to get the answers we need. So a couple things that are kind of new. What's new here? Well, first of all, reviews, like deep, detailed product reviews, a lot of us grew up with in the 90s, networking gear, all that stuff, that industry's dead. It's gone the way of the dodo. All this print media and reviews and whatnot, everything fueled by that industry is gone. We're not going to get good facts or data from magazine reviews of software security solutions. So where do we turn? Well, online media, it's driven by advertising similar to print media, but it's categorically different. It's driven by view click rates, and online reviews, by the nature of their funding models, are going to have suspect to superficial value. We already see this today in the online reviews, and note the ad placement strategically. I've written detailed things and had all the facts and meat pulled out. I've had tables and charts and spreadsheets, and they summarize it in something pretty and happy that makes the vendor want to throw more advertising revenue in there. So what is left? Well, we have analyst reports, right? So like Gartner, and the last I checked to get on Gartner's good list, to even be considered for the right magic quadrant in Gartner, costs you a minimum $25,000 a year retainer to do business with them. Independently objective, not so much. It's a pay-to-play industry. Anecdotally, a year ago in Boston, I met one of the gals from Gartner who was working on reviewing this space. She was a really nice gal from London. But the thing that was really fun in talking to her, she was really excited to hear about some of these new things like cross-site scripting and horizontal and vertical privilege elevations. So it's a pretty neat conversation. Before I start the stats slides, I have two questions. Do we think, if we're approaching a problem domain, like how secure is our software, do we think that math and measurement is important? Does anybody agree that would be cool? All right, yeah, okay, we got agreement. The second thing, is anyone here familiar with the history of the software-driven, multi-billion-dollar U.S. missile cruiser, the USS Yorktown? Okay, someone in the back is. All right, so what's neat is on September 21st, 1997, she was the world's most software-driven, state-of-the-art missile cruiser to defend against all sorts of evils. So what happened to her? Well, she was shot dead in the water for 3 days. Why? This is interesting. This does relate to WebAppSec, I promise you. We're getting there. It's really quite simple what happened to the Yorktown. Back in most unrecorded BC history, a dangerously inquisitive group of people, who you know is for building an infamously fateful tower, discovered the math and metrics they needed to do their Babylonians. They invented, the best we can tell today, two funny things: non-base 10 math systems and binary systems, base 60 systems, non-base 10 math systems, and most importantly, they introduced the concept of zero. So they took our Yorktown from this. So, but they didn't stop the Yorktown, actually. It wasn't the Babylonians. You see, when Alexander the Great Persian's armies took zero to India, they called but it wasn't actually the Indians that stopped the Yorktown either. You see, somewhere between 600 and 700 AD, the Muslims conquered India during outsourcing disputes. And the Muslims discovered and patented, I believe we call it in the WebAppSec industry today, the Muslims patented the concept of zero in the Indian math system. That's why today we call it the Arabic numeral system. So they, the neat thing about this is merchants worldwide rejoiced because they now say. Now in 1202, wasn't the Muslims that sunk the Yorktown? 1202, Fibonacci, whose name I can't spell but painfully remember from biology class, introduced zero to Europe. A little book about a fascinating sequence, but what was neat is Fibonacci measured things using an accurate numbering system, including zero. And from this measurement of metrics, he deduced all sorts of subtle dependencies, things that we don't even know about our software today. He did this using only mathematical measurement, not philosophy, theology, speculation, top 10 lists, scanners, bullet points, or marketing slides, just metrics. So, where are we at here? All right. The Catholics in Italy, who pioneered top 10 lists for sins and prayers, almost saved us. So, the Catholics banned these deadly Arabic numbers because they're cutting the profits, their abacus. But the infamous merchants of Venice ultimately played a part in WebAppSec, actually. The merchants of Venice played a part in WebAppSec and the Yorktown's demise, and all the stats you're going to see today. So, while the Muslims were rejecting Plato and Aristotle, the merchants of Venice were profits, provide stock options, preferred customer pricing, and competitively align employee wages using this new math. So what does this have to do with software security? All right. Can you tell? It's pretty obvious. No? Okay. So finally, we're coming to the point here. Finally, in 1425 AD, the Yorktown's fate was sealed in software numbers. A painting of a monastery by Brunelleschi, which I couldn't find a picture of. And incidentally, the Renaissance of Arts and Science launched this first. This little book contained a divide by zero operation, and math and metrics were introduced into painting. The first mathematically precise painting that captured perspective of building and structure was created in 1425. So what happened with that? Well, Greeks cried, Muslims rejected Plato and Aristotle, Jews quit trying to rewrite Genesis, Christians found 8 different ways to translate John 1:1, Y2K and brood conversion panic ensued, but more importantly to us today, programmers counting 1 through 9 in their software shuddered a little bit, and the web app security industry was born. No joke here. Everything you know today about metrics and measurement, cost-benefit analysis, quantitative and quantitative measurements, and statistics probably comes from formal mathematical analysis and ensuing metrics that led to a painting in 1425. It's a long time ago. So right now, I bet every one of you in the room is asking yourself, I suspect you are, where are the bookkeepers of the software security industry, right? Where are the bookkeepers and the auditors who can tell us what our vulnerability balance sheets are on our software? Where are these people? Well, funny you should ask that. So, 50 years after that painting in 1425, double entry bookkeeping, started by the same movement in Italy, became a fully ratified, formally accepted mathematical model in France, actually, as a word. Amazing. So in case you wondered, pencil pushers came from painters. Otherwise, what about the USS Yorktown? I'm not very good with slides, I should have really obvious here. Come on. Let's escape out of this. I have a clicker thing that I don't know how to use. Okay, so what does this have to do? How do we sum this thing up? USS Yorktown, 572 years demonstrated the value of metrics and measurement. 522 years after bookkeepers caught on to the value of measurement. Confusion over how and what to measure was actually what ground the USS Yorktown to a shuddering halt. You see, the Yorktown couldn't count, she couldn't measure, she didn't understand metrics. She was just a blind automated machine. The Yorktown only knew 1 through 9. She didn't know a false positive. She didn't know what a false negative was. She had no notion of the threat and attack landscape she was operating in. She was blissfully unaware of what was going on. But when she was asked to divide by 0, she simply stopped. And my friends, 10 years later, it appears that today we've been doing the same thing when confronted by a mass of zeros in web app security. Our industry hands us nothing but zeros and pretty marketing sticks, and in the last decade, very little seems to have been done to actually change this. We really don't know what the landscape looks like out there. The numbers we're going to discuss today aren't perfect. They might not even be 100% accurate. They are, however, the best numbers we've been able to come up with. They're better than snicking around on an abacus and speculating about what our top 10 issues are, or we can go out and measure them. We can fantasize how well X, Y, and Z solutions find and fix our issues. But that only leads us to guessing how to take action in the real world. So if you're still awake, I would like to give you an opportunity to choose your presentation. That's my bookkeeper slide, just kind of Which web app sec field do you want? Basically your options here. So we have 2 presentations. You kind of choose where we. Number 1 is we take the red pill, and you get objectively measured factual data from weekly testing of roughly 560 to 620 real-world production websites, mostly production. The blue pill, I can certainly go down this slide deck route, is I can give you lists of cool-sounding bullet points generated by a marketing department based upon what features our widget provides. And we can also discuss a taxonomy of key issues based upon a speculative notion of security that someone with a PhD, probably working with government. So, preference? Vote?
Can't we mix our medicines?
No, you can't mix, James. That's the whole point of this.
Purple. We're supposed to pick the red pill, right?
Alright. Back to staring at my slides like the horrible presenter I am. Oh, my clicky thing. I wonder if this thing will work.
Right here.
Alright, websites. You guys all know what they are. Well, I'm hoping, especially if you're here at eBay. Basically, this is, in case you're not aware, there's a lot of websites out there, and they do a lot of different things. And they're powered by software. Here's some names that you might be familiar with. And we know that's going on. What are consequences? Loss of business, hard to quantify. Brand reputation and market goodwill, damage to stakeholder confidence. Financial cost to handling an incident, that's actually a legal issue over in parts of Europe. Impact to internal productivity, regulatory fines, possibly insurance in the future. Where did the data come from here? Well, the details here, this was captured between January 2006 and August 2007. Includes hundreds and the largest and most popular websites, retail, financial, pharmaceutical, insurance, education, even some social networking, quite a few healthcare. We'll slice it up by vertical, so you can see how different industries vary.
This is all remote and external black box assessment data, typically captured on a weekly assessment basis. We use the Owasp threat classification as our categorical baseline. So we organized all the issues and defects we found along the Owasp threat classification. We're focusing 8201 of my PHP crap is vulnerable to remote file include exploitation again. So if you don't run, PHP, whatever, network vulnerability scanners typically look for this version detection. So if we ran into a piece of software that had my PHP whatever glued into it and it had vulns, we find them on the fly, not by version matching. So that data would be in here, it just isn't aligned with the specific product and version number. You can go review this later. Basically, we break down what things we think we can accurately automate and what things most commonly require human context out of the 24 issues. One thing that was really interesting over the last 12 months is our metrics regarding how many pieces of software have issues. It's actually, I believe the current number is 93.5% of web software that we look at has a critical exploitable vulnerability, something we can directly exploit in. About 80%, now it's 93.5. So how bad is it really? 34% have an urgent issue. On your 1 to 5 scale, this is why this is red, it's the more important of the issues. So 34% have urgent, 80% have critical, and I believe, Jeremiah, I thought this was 93.5 now.
When you take it all together.
Oh, smash it, okay. 71% high, well you can read the rest of that. So how about all right, top vulnerability classes. This is probably no surprise to anyone who's tested much software out there. What do we have? We have cross-site scripting. That's way number one. Information leakage. That's a catch-all for a lot of different things. That could be anything from credit cards and social security numbers to internal IP addresses on networks. That tends to be at a pretty high rate because when you find it in a site, you often find it everywhere. Authorization, those are huge issues, and it's interesting, we still find these, when you plug those two together, that means over 30% of software still isn't adequately addressing authentication and authorization, pretty basic concepts. What's not there in this data? Xpath Injection, if you've seen older versions of this presentation, you'd see Xpath Injection. It's been pushed off the list by response splitting. We're not covering implementation flaws in basically buffer and heap overflows, format string bugs, anything that requires a local debugger on a web server to be able to actually exploit, we're not covering in here. No scanner can find these reliably at all, despite whatever they perpetuate. Basically, scan vendors use an example based upon this one specific edge case of Microsoft Windows 2000 and IS5 and a SAPI filter that statically maps to a known memory region, so it can always be predictably remotely exploited. Regardless of how the software is written, this SAPI filter plugin architecture always sticks things in the same region in memory, so it can always be reliably, remotely exploited as a buffer overflow. But aside from that one exception, I don't know a single other out there in the world that you can actually do that without a local debugger. We're not going to run buffer overflow checks. Oh, if you do have a scanner that has buffer overflow checks, you're probably only going to run them once on your production software. And when you do, you want to look for the box that says generate resume in PDF, doc, and text and check that. SRF remains very difficult to find in a meaningful fashion that people actually care about, right? Because the problem with cross-site request forgeries is it's kind of how the internet works by design. So you can easily tell a scanner, go find anything you can replay. But the question is, do we really give a darn about it? And that's actually a much more difficult problem. Today you have to have human context to find cross-site request forgeries that actually have security implications. And what we're finding is even when we find them and communicate them to our clients, for example, few people understand, which means even fewer see any importance to the problem, which means no one today really seems to care about it or fix it, is what we're finding. So that'll probably change with awareness and impact. Overall vulnerability population, here's a prettier pie chart. Cross-site scripting, SQL injection is still maintaining a respectable 5%. Likelihood that a website has an urgent issue, 16%. And what is it? It's SQL injection. SQL injection, What is the problem with that? Well, you know, basically you have a remote command line processor on your internal network now that a hacker can do things with, so that's a pretty bad one. Insufficient authorization, that usually has pretty alarming business context, so those are your two biggest there. Urgent, let's say critical. Cross-site scripting. I think everybody probably expects that to be at the top of this. Insufficient authentication, I'm actually just stunned that 14% of software still can't handle authentication properly. That's pretty amazing. Abuse of functionality, that's another catch-all bucket that can mean things like you've got a form that can be turned into a spam relay, for example. That's what abuse of functionality would be. High, what do we have here? Informational leakage, not surprising. Content spoofing, this is really the poor man's cross-site scripting. You can manipulate content in an application, but you can't actually execute your own arbitrary code. So that's what content spoofing is. Predictable resource location. This could be anything from forced browsing down past to guessing. You know, you don't have your permissions set properly on your IIS server, so you can get to global.asax or machine.config by forcibly requesting it.
Excuse me? Can you just comment why information leakage is just high and not critical or even urgent? I mean, if you leak like credit card numbers.
It really depends on business context, right?
Okay.
So this represents our aggregate prioritization. Someone might want us to put something at a 5 and prioritize it, but likewise you might have some that are a 1 or a 2, like RFC reserved IP addresses that it's leaking out. So you know all this internal IP addresses, the servers, it's not great, but it's not probably going to change the world. I mean, I don't think many people are using packet filters in front of their production systems anymore, so knowing internal IP addresses is kind of irrelevant. So it's just an aggregate smush of those values. Did everybody, the question, why is because it's a smush of different issues.
What's the difference between an urgent and a high responsibility issue? You have that listed as well.
We're going to talk about that towards the end. Thank you for bring that up again, please. We're going to talk about responsibility at the end and why that's different. Comparing industry verticals. Retail. Now, isn't that kind of interesting? Probably you guys excited to see this. Retail is actually in much better shape than everybody else. Thought about it, I'm going to make some wild speculations on this data, but I think it kind of makes some sense. So, what are the top 3 issues by vertical? If you find this interesting, retail cross-site scripting. I think this is important. We'll see why in a second. Retail cross-site scripting. Also, retail has predictable resource location. I think there's specific reasons for that. Financial, SQL injection. It's one of the few SQL injection gets on. I think there's a reason for that. Absolutely no idea. I'm going to make something up later. And IT kind of fits the norm of all software out there, so it's not too exciting. So this is our first pass to look at platform technology. Well, you know, I mean, come on. Hopefully all of you know that Microsoft brilliantly enabled everyone to shoot themselves in the foot with, you know, ASP.2.0 and 3.0 technology and plugging, you know, dynamic SQL queries. Banks across the internet that I dealt with when working with the Secret Service and FinCEN they were all targeting ASP apps. It was all ASP classic stuff because it's usually pretty bad. ASPX 10%, there's some neat built-in native security controls, but a lot of WYSIWYG, you know, Visual Studio type developers don't understand what they are, and so if they stop them from putting bold tags in their instant messaging function they just wrote, they turn them off globally. Java's got its issues. Cold Fusion. Cold Fusion, actually we need to break this down by which CFMs. It's the ASP stuff that's absolutely horrible. Cold Fusion starting with MX, what was that, 6? Moved to a J2EE type platform, and today it's actually fairly robust. Just miscellaneous HTML things, and then unknown, 32%. You know, a lot of your MVC frameworks make it hard for us to detect exactly what the technologies are there, so you ready? Server-side attack surface because it's all pre-tested. What do I mean by that? Well, you don't have to have a relationship with Amazon to exercise almost all their functionality, right? You don't have to have an account until you go to the very end and want to check out your shopping cart. So you can actually exercise and gain access to almost all the software as an anonymous entity versus financial is very different. Increased client-side attack surface, increased reliance on user-supplied content. You know, what a lot of user data and does stuff with it. So I gotta be careful about Web 2.0, Joey Hoffman. Wish you were here, he could clarify all that for me. Highest rate of PRLs. Why do we find predictable resources more in retail? Well, I think it's because they have tons of web servers. You have a commensurate number of lines of code. It's hard to manage all of that. So we find backup files, source code files, all kinds of stuff on retail more than anyone else. Financial. Wow, more roles in retail. That's still kind of crazy. So financial apps, they don't get free pen tests in the way that retail does, because typically you have to have a relationship with a financial services provider before you're allowed to test their software, and that relationship usually involves money, a geographic location, some identity checking. It definitely raises the bar over going to Amazon and poking and prodding around. SQL injection. This is a wild, wild guess, but I know when I had to help build financial apps that I a lot of times had many disparate data sources. I might have 5 or 10 different data sources I had to go out and grab data from. So a lot of the data gathering tended to be dynamic SQL queries, and I think that's why we see more SQL injection on financial than anyone else. Insurance, large amount of private regulated data to gather. There's also complex relationships between user, customer, agent, partner, and reseller relationships. We have some very, very complex authentication and authorization requirements in insurance. And authorization. Pharmaceutical, actually statistically, they're pretty normal. Not that that's good, but it's normal. So IT, yeah, XSS. And the one thing that I find that's so interesting is a lot of times people go, oh, we found all this stuff. Vodka's so good. We found all this stuff, but it's like, it's our intranet. We don't, why do we care? There's not even that much sensitive data. I go, yeah, but how about your general counsel's laptop? Does she have any sensitive data on there, right? How about your CFO's laptop? Did they have any sensitive data on there? They go, what the heck does that have to do with her intranet? I go, well, you run IE internally, right? Yeah, and use Active Directory, right? Yeah, and all these servers are in the same domain as the clients, right? Yeah, and that browser, right? It's probably running things in right? And I can write my own and plug them into these apps in domain through my cross-site scripting, right? Well, yeah. Well, I'm not, yeah, we're not on the same page here. So again, you're telling me IE runs this like full local system privileges, and I can push ActiveX controls on the fly through cross-site scripting and really do anything I want with the client. Yeah. So I can gain access to the hard drive of the client. Yeah. That's why your intranet apps are important. They go, oh, okay, so the apps themselves might have a perception of less value, but what you can do with them internally, especially plugged into a Windows network, is actually pretty disastrous, because you can get a large degree of control of clients, and it's much easier to get like full access to the file system that you'll normally never get from an internet-based cross-site scripting attack. Common properties is sites that tend to behave more securely. But what do? Okay. Use of modern development frameworks. Typically, the more frameworks are really good at solving yesterday's problems. And luckily for us, most of these problems have been around for like 7 years or more, so it's not like anything's new, really that new here. Some security involvement in the SDLC. We find that people who do awareness training, threat modeling, try to incorporate this in QA, they definitely have more robust environments. People actually prioritize vulnerability remediation. Believe it or not, people who prioritize vulnerability remediation tend to have better software. For example, we have some clients that don't prioritize vulnerability remediation. They have the same remotely exploitable SQL injections open, say, that are 2 years old. And they tend to have a lower security posture than people who actually track and prioritize the vulnerability remediation. So we recommend this as a best practice. Solution approaches that appear to help. Asset tracking. I mean, gosh, everybody who's worked in IT knows asset tracking, and I'm still amazed how many people come and go, hey, we think we have like 500 websites. Could you help us find them? You're like, we're hoping you could give us some direction. Measure security. Obviously, you can't make any smart decisions about what you can't measure. You know, why is that obvious? Gosh, maybe it isn't. Every other industry seems to get that besides ours. So, security measurement. Development frameworks, give developers frameworks, tools, basically make it easy, especially if you hire a lot of fresh out of college new developers. You're going to have a real problem internalizing security practices. I think we're doomed for failure there. Okay. So we found out something new and interesting recently. HTTP response splitting. We're going to talk briefly about what this is. It showed up on our top 10 list as a result of implementing new tests and changing tests. And what is it? Fine, it's really hard for people to get their head around. So actually, let's start at the bottom. What is content spoofing? Content spoofing, you can create, update, or delete, basically manipulate content generated by a piece of software, web application. That's content spoofing. What is cross-site scripting? It's basically content spoofing plus plus. You can create, update, delete, plus you can write and execute arbitrary script at will. This allows you to do stuff. If you can do cross-site scripting, you can do all sorts of stuff. Your limitations are basically dictated by browser scripting language support. You know, Safari on an iPhone doesn't support LiveScript or Mocha, for example, but Netscape and Mozilla do. The amount of free time, the IQ of the attacker. So, what is response splitting? Well, it's really related to this in a hierarchical fashion. If cross-site scripting targets the message, we got this message there in the page. If cross-site scripting targets the message in the page, response splitting targets the envelope that the message is delivered in. So, with HTTP response splitting, you control the envelope and the message. Basically, it's cross-site scripting plus plus because the other implications, there's actually quite a few other implications, browser cache poisoning and such. I'm not interested to go into anything that's unrelated to the server-side issues. So what did we learn about this? Well, there's the first paper written on HTTP response splitting by Amit Klein. It's actually really good and really detailed. I got to the part where he talks about browser cache poisoning, and I was like, yeah, I might have gotten it. The other thing is I was fixated on, I tried to exploit some 200 OKs and wasn't having any success and went, nah, and I forgot the fact that ASP Classic software, actually quite a bit of Java software, actually quite a bit of software in general, but particularly ASP Classic and Java, love to take user-controlled URI data and throw it in the location header on a 302 redirect. It's a very common behavior. So then you're actually into the protocol itself. And I just didn't even think about that issue. So there's many faces. You should read Amit's paper to cover all the faces, but there's three we're going to talk about today. And those three relate back to why we would rate them at a different level. We've struggled with this internally. People have had a really hard time understanding this too, so we've struggled with how to rate the threat of this. Nobody out in the wild is attacking this yet, I'm pretty sure. If they were, we'd know about it. If people were exploiting this, we'd totally know. Most smart people being exploited can be really bad. So it starts with control character injection. This, what most people call response splitting, is really just control character injection. You can add an arbitrary header. How are we for time?
Supposedly you got 5 minutes, but we got 20 minutes for break after that.
Well, I've tried to rush through this so we can get back on track. HTTP protocol control, you own most of header space. What can you do if you are in header space? You can set your own cookie at will. So if an application is vulnerable to session fixation attacks, you can go harvest session cookies, and you could potentially arbitrarily overwrite someone's cookie instead. You could change a cache setting, for example. If you want to facilitate a browser cache poisoning attack, maybe you could make something cached for much longer. Alternately, I was just playing around. This just got added in last night. I didn't even think about it, but you know, HTTP has that wonderful function called connect. So you could actually force arbitrary TCP connections using header injection. It just dawned on me. Response splitting. This is the next level. Actual response splitting is, can you break into the HTTP protocol and create your own arbitrary HTTP response? There's lots of dependencies and questions you have to ask. This isn't a binary yes or no. There's many dependencies, but can you get in and create your own response? And you have to ask, what browsers will this work on? How do 302s differ from like 200 OK? Legitimate response coming from the server into two, and then get the browser to look at the second one, the fake one or the arbitrary one you created, and actually process that request. If yes, then you have response splitting. The third level, and this is where we raise the threat of an issue that we started measuring. It was actually really interesting. I thought our software was broken. So we implemented some new response splitting tests, and the data was no no sense to me, and I think it's clear from my slide deck management that I'm not the brightest person in white hat, but the data, it took me about a week or two, and I was like, what is going on? What is wrong? And I'm digging technical rabbit holes and getting lost down in the weeds, and because what's happening is we're going around and we're making these control character injections. We're getting responses back, but then they start multiplying, right? And WebAppSec, I don't think is quite like the Fibonacci sequence, so these things shouldn't be breeding out there. I'm going and I'm making directory traversals around sites, and I'm getting back split responses, and I'm like, something's really wrong here, and I'm pretty sure it's me. Challenge my own brain here, but actually I was wrong. It wasn't, in fact, well, it was me that I didn't understand it, but it wasn't our software. Our software was doing the right thing and responding correctly. What happened is there were a lot more people using intermediary caching proxies than I realized. Piece of software and split a response coming back, it would get trapped in the intermediary caching proxy, and anything you did to go back had a, now you got a one-to-many relationship. Anyone that goes and requests the same type of request in the same type of state is going to get your poisoned response with your arbitrary code back. You're like, oh, that's bad. But it actually gets worse, because not only is it one-to-many in terms of people, but it's one-to-many across the site. Because if you go start poisoning and replacing global error message or redirect that Sally gets, and she gets a different pricing model than Rob, now you've got horizontal privilege elevations. If it's a global redirect, or if it's an error page that administrators can potentially get, right? Now you've got vertical privilege elevation. Even better yet, on an intermediary caching proxy, is if you've got a page that builds and then checks for authorization and then redirects you to an error message, say create admin user, you know, form, it's going to come back and it's going to give you an error message and then redirect you off somewhere else. But the cool thing is you could poison that. You could poison that response. So what happens is, without having access to the admin interface, you could actually poison that content in an intermediary cache. If somebody were unsmart enough to cache admin content, then when the real admin comes in to create user, they'd actually be using your form and doing whatever you specified in there. So it actually turned out to have much than I had possibly fathomed.
What's the time, the duration that it's caching?
Oh, so that's a good question. So what several people told us is, well, that attack doesn't really matter because we set our caching timings very low. We don't cache for very long on our intermediate caching proxies. And I said, look, you're correct. You do have a point there. You were doing that. How were you setting that in the past tense? And they go, oh, through the HTTP headers. And I go, right. Now we control those. So, all right, went really fast. We're back on track for time. Thank you for humoring me.
Thanks for humoring us.
I hope you don't have any questions.
Or we can eat into the break, so I mean, as long as you guys want to stay.
So, does anybody have any questions? Please no. Anybody follow this? Need more pictures? I barely. I don't. Jeremiah Grossman, my boss, put this together for me, so I just kind of hit the button.
There was a lot of blue pill in there, I think. A little bit of blue pill. There were a lot of bullets.
Oh, there were bullets, but not marketing bullets. That's another slide. Seriously, does anybody have questions? Please ask if you do. Concerns? Legitimate complaints? Okay, I'm so out of here.